The last thing I want to talk to you about today with simple machines is efficiency. How efficient is a simple machine? Basically, what that means is how much in a percentage does a machine convert work in into work out? Machines are not 100% efficient, and the reason for that is they lose energy to friction. That's kind of a big deal. You lose energy to friction. And because you lose energy to friction, what you put in does not always become what you get out of it. You will never, ever, ever get more work out of a machine than you put in. A machine, a bar, or whatever, can't create work for you. It can only take the work that you're given it and make it easier, but it also at times will lose, because of friction, will lose some of the energy that you've put in. So let's talk about how you measure this. Here's the formula. Work out divided by work in is going to be your efficiency. If I'm finding efficiency, I'm going to multiply it by 100. If I am using efficiency, if I already know it, then to put it into this equation, I have to divide it by 100. Let me show you what this looks like. Work in is 600 joules, work out is 500 joules. What is efficiency? I know that by the time I'm all done, I'm going to have to multiply this by 100 because my answer is always going to be in percentage. I am finding efficiency here, so I'm going to have to multiply it by 100. So here's my equation. My work that I got out of it was 500 joules. The work that I got into it, or that I put into it, was 600 joules. And I'm looking for the efficiency. When I'm all done, I'm going to multiply the whole thing by 100. So 500 divided by 600 is 0.833. So I end up getting my 0.833333333, whatever. But now I'm going to multiply it by 100 so I can get a percentage. It is 83.3% efficiency. If I know the work out and the work in, I divide work out by work in, and then I multiply my final answer by 100 to get a percentage. Now I want to find out how much work in I need in order to move my 500 newtons. So I should actually write that down. What work do I need to do? So now you'll notice that what's happening with this one is that I already know efficiency. So now I'm going to do this. I'm putting efficiency already into my t, so I'm going to have to divide by 100. So what I have then is my work out is 500 newtons. And I should do this. I'm going to expect you to do that as well. So I should be putting my knowns and my unknowns here. My work in is 600 newtons for this one. The work out is 500 newtons. And I'm looking for efficiency. Now here my work out is 500 newtons. My efficiency is 90%, but now I have to divide that by 100. So that's going to give me my 0.9. So whatever goes in here should always be a decimal. If I'm putting the efficiency in, it should go in as a decimal. And I am looking for my work in. So my work out is 500, and it should be, I shouldn't say I need to move 500 joules. I need to move, let's put it this way, I need to do work of 500 joules with a 90% efficiency machine. Sorry, I just was doing that too quickly. Joules is always my unit for work. So my work out is 500 joules. I know that my efficiency is 0.9, and I need to find my work in. So then I'm going to, what do I do when it's these two together? They're over each other, so you divide. So it's 500 divided by 0.9, which gives you 556 when you round it. Work in is 556 joules. Now I'm always going to ask myself, does this make sense? Yes, because work in has to be at least the same size or bigger. It will work out will never be bigger than work in. Work in should be bigger than work out. So yeah, I look at that and I say, yeah, I had to put more work in than I got out of it. That's what happens because of friction. Okay, so with all of that, you should be able to finish up the homework today. Let me know what you need.